edge of a cube. If the cylinder and the cube have the same volume, what is the radius of the cylinder? Okay, well, volume of the cylinder is 2, pi r squared times the height.
Okay.
And volume of a cube is length times width times height.
About side length cubed.
Mm-hmm.
Okay. So, what does the first sentence say?
That the height of a cylinder is equal to the edge of a cube.
So we can essentially...
As an age is the same.
Right. So let me replace that with h cubed.
Yeah.
And now what?
One second. It should be. Do you just put them equal to each other and find
Yes.
H?
Well, right, because they're saying the volume of the cylinder is the same as the volume of the cube, so I'm going to let this equal this.
Yeah.
And now, what is the radius of the cylinder? So we want to solve this equation for r.
Okay, so you put H on the other side.
Okay.
Divided by H. Yeah. Yep.
Now simplify.
2. And then you have to take the square root of that.
Okay. So the square root of h squared is h.
And then pi squared.
Square root of pi.
A is the right answer.
Right, right. You don't often see a square root of pi.
No.
Okay, let's see. I gotta go to another page
Well,
here.
as long as you don't have to calculate it, then
Yeah, really. I've always wondered about dividing by pi because they don't like dividing by irrational numbers. But when you divide by pi, you necessarily do have to divide by an irrational number, and you can't rationalize it. There's no way to rationalize pi. Hold on a moment. All right. Now, let me just widen this thing a little bit. There we go.
Okay. A rectangular tank has a base that is 10 centimeters by 5 centimeters and a height of 20.
Let me draw this a little better then. Height is 20, so it's 5 by 20. And this is 10.
Sorry, excuse me.
Okay, I've been doing it to everybody for the last 4 days, so no need to apologize.
Okay, and then if the tank is half full of water, by how many centimeters will the water level rise if 325 cubic centimeters of water are poured into the tank? Well, first you would have to find the volume.
Okay. Of
of the um, rectangle or of the box.
Okay, that's one way to do it. What's the volume of this box, this rectangle?
It is 500 or no?
5 times 20 is
Oh,
100. 100 times 10 is 1,000.
1,000. Sorry.
So
Yeah.
the total volume is 1,000, which makes the volume down here 500.
500.
And they're saying that if we add 325 cc's to that, what is this dimension going to be here? How high will the water level rise, which is h?
Mhm.
Okay.
Um. Hmm. Well.
Let me give you a hint here. If I didn't know this was 20,
Mhm.
but I knew that the tank held 1,000, how would I figure out what the height of the tank was? In other words, if I knew its volume, here's a different problem. A volume of a rectangular tank is 1,000,
Mhm.
and its width is 5, and its length is 10. What's its height?
Well, I would say 1,000 divided by 10 divided by 5.
Okay, which is 20. So that's the way we would get that 20, but we have that 20, but this is a problem that's around that. In other words, if we know that we have a volume of 325 and that directly, without even figuring out the volume of the whole tank, that will tell us H.
325 divided by 50. That's 6.5.
Uh-huh. And that makes a lot of sense that that would be
It's kind of weird
6.5.
that I wasn't in no doubt, how to do it when you put in the 1,000.
Uh-huh. Mm-hmm.
So it's like funny like how it threw me off. Said it was like
Well, we didn't really need to calculate the volume of the tank. We only needed to deal with this space that was going to have increased water in it. But the advantage of figuring out the volume of the tank is it taught us how to think about H.
Yeah.
We now know how to figure out H. So now we can do the problem directly by just looking at this little space.
Mhm. If the height of a cylinder is 4 times its circumference, what is the
Circumference? Uh-huh.
circumference? Sorry.
That's okay.
Yeah.
I'm only correcting you because you're Danish, and I know you want to learn the proper English pronunciation.
Yes, that's fine. Circumference.
Mm-hmm.
What is the volume of the cylinder in terms of its circumference? C. Well, volume of a cylinder
Okay.
is pi r squared times height.
Okay. Volume of the base times, or the area of the base times the height, which is
Mhm.
useful to look at it like that.
Mhm.
What's
And
the
you
other
know that
equation?
um that C is equal to Oh no, H is equal to 4 times pi r squared.
No. 4 times the circumference.
Oh, sorry, so that's 2 pi r.
Yeah, that's okay. I almost didn't catch it. Okay. However, do we want to use 2 pi r?
I want to use C.
Right, because all of our answers are in terms of C. We've lost C, so let's put it back in. And now let's figure out the volume of the cylinder in terms of C. So what are we going to write?
You've got pi r squared times 4c.
Okay. And that answer is 4 pi. What am I missing here? Oh, notice that none of these answers have R in it.
Uh-huh.
So we need to substitute for R. What is R equal to in terms of circumference? If circumference equals 2 pi R, what is R equal?
R is equal to c divided by 2 pi.
Okay, and now let's substitute that. So now we have pi, and in place of R, we have c divided by 2 pi. We need to square that, multiply it by 4c. And then when we simplify this, we're going to get our answer.
Okay, so we have, okay, keep it straight. There's a lot of numbers there. So you have pi, and then you have c squared divided by 4 pi.
Squared.
Squared, yeah.
You have to square the pi, okay?
And then 4 times 4c.
Yes. Doing it the way you just did it is definitely the way I'd recommend it. Don't try to do it all at once. Take it in steps. And then cross that, cross that, cross that, cross that. And we've got c cubed over pi.
Divided by pi.
A. That was a hard question, but really more hard algebra and more understanding it, I guess. Let's see. This is a fill-in. Do we want to do this one?
It's just like I won't see that on the...
No, you won't. I'm just wondering whether you'll see the mathematical principle on the test. But we've got no shortage of mathematical principles to cover, so let's... Okay, and so we're done with solid geometry. So let's go to coordinate geometry. Coordinate geometry is XY.
Oh, yeah. It's the whole with the slope thing.
And if there's one thing you need to know how to do, it's calculate the slope that goes between 2 points. So let's go ahead.
That is y2 minus y1 divided by x2 minus x1.
Okay, so what is that in this case?
I'm sorry, I'm just going to write it.
It's okay. If you want to say it, I'll write it, and then we can kind of share our...
Oh, sure, yeah. Okay, so y2 is 0 minus 2 divided by 3 minus 0.
Okay.
It's 2 divided by 3.
Right. Okay.
Oh.
This is what they mean by coordinate geometry.
Mm-hmm. Yep.
Okay. So we have point. You don't always need to do this, what I'm doing here. I'm doing it primarily more for...
Oh, I always do that. I always
You
end
always
up
do
writing
it?
it.
Okay.
Yeah, so I can see it, because sometimes
Uh-huh.
I've realized that if I can see it, I make less mistakes.
Uh-huh. I agree.
Because
But,
you can actually see that
right,
makes no sense. You definitely did this wrong.
right. Okay, so there's our triangle. What is the sum of the slopes of the three sides of the triangle?
Well, you would have to calculate all three slopes.
Okay, we can actually do it pretty easy. What's this slope here?
It's 5/2.
What's this slope on the bottom?
Um, 0.
And this slope here?
Um, 5/7.
It's using the formula you gave me, it would be 0 minus 5
Oh,
over
so
7
-5.
minus 2. So that would be a
So
negative 1.
-1. Sorry, yeah.
So what's the sum of our three slopes?
Well, 0 plus -1 is -1.
Mm-hmm.
And -1 plus 1.5.
5 halves is 2.5.
2.5, yeah, sorry. So -1 times 2 is 1. So it's 1.5.
Right. Okay. And that was a case where, I don't know, I guess in retrospect the picture wasn't really needed because what we did was algebra, as all we did was figured slopes between each pair of these 2 points. But the picture certainly helped.
Yeah, I don't know. I just like drawing it because then
Mm-hmm.
I can like see it. So
Mm-hmm. Okay, so let's draw a different picture on this one. Let's see, we got a minus 1, 1, and b at 3 minus 1. Are the endpoints of one side of a square. What is the area of the square?
you have -1.
This is testing one key principle, and it's the distance between 2 points. What's the formula for that?
That one I'm not sure I know.
Think Pythagorean theorem always, because the distance between point A and B is always the hypotenuse of the right triangle that you would come up with. So if I'm solving for D, distance, it's going to have to be square root of the sum of the squares. Well, the sum of, or this one is the differences in the y, so that's y 2 minus y1 squared plus the differences between the x. And this is definitely something you need to know for the GMAT, is distance between 2 points on a coordinate plane.
I think it's funny it's not in the Kaplan book.
Really? Yeah.
I'm just looking it up right now and it's not there. The other one, the slope is there, but this one is not. That's kind of weird.
Yeah. Well, you'll get a variety of questions on distance between 2 points, I believe. And it's pretty simple if you remember that it's just the hypotenuse of a right triangle, whose sides, this side over here is delta y, and this side is delta x. Not to introduce any new terms, but we're talking about the change in y, meaning y2 minus y1, and this is the change in x, meaning x2 minus x1. This is actually not the Kaplan book. This is Barron's, GRE, but I have the Kaplan GRE and the Kaplan GMAT, and they both have identical arithmetic, algebra, and geometry sections, word for word. So,
yeah, I'm just wondering why that formula is not in there.
oh, they give you a list of formulas, and that's not one of them, huh?
Yeah, so like for every chapter, they give you a list of all the formulas you need to know.
Ah,
And so
okay.
I made flashcards of all of them. That's why I know
Ah,
most of
that's not one of them. Yeah, that is interesting.
them. And it wasn't one of them, and so I just thought
Huh,
that was really weird.
huh, huh. Well, it's possible they've made changes, but I'd be surprised if that's not on there. That's a pretty common thing taught in algebra here, and tested on for the SAT and the ACT. All test that principle, the distance formula. So, okay, let's look at this one that we can barely see. If the area of circle O is k
Well,
pi.
we didn't calculate the other one, did we?
Oh, no, we didn't. The main thing is just knowing what it is, but let's go ahead and,
Well, it's just since I've never done it, I'm just calculating
yeah,
it
no,
out.
I forgot to. So
Okay, the
y2
O
minus
first,
y1 is what?
it's 2 squared
Okay.
plus 4 squared.
So this is the square root of 20, which simplifies. And we don't need to simplify it. You know why? Because they want the area of the square. So simplifying square root of 20 would just be an extra unnecessary step. If one side is square root of 20, obviously the area of the whole square is 20.
It's 20.
Yeah, would be C. But that would have been tough to get without that distance formula. We'd
But
have
I
to be
just wrote it
calculating.
down.
What's that?
I said I wrote it down right away
Yes. Okay.
on a flashcard, so now I got it.
All right. Let's see. This circle area is k pi. What's the value of k?
Um,
And
well, I
this,
would say that radius um, is really hard to see. But is O the middle?
yes. So how do we get the
I would
radius?
say
What's the distance? What's that distance right there?
wouldn't it be 3?
No, use the distance formula.
But I only have one set of,
Actually, we have two. This is 0, 0.
oh. Well, then you have 3 minus 0, which is 3,
Okay.
and 0 minus 3, which is minus 3.
Mm-hmm.
But they're squared, they're both 9, so it's squared 18.
Okay. So that's the radius. So the area of the circle is pi r squared, which they've told us is k pi.
So it's 18.
Okay. Why it really matters where the lens is over the paper, apparently. This is very readable, and yet it was the same camera shot.
Mm-hmm.
Okay, we have 2 points, or 2 of the vertices of a rectangle. Which of the following could not be another vertice?
What is a vertice?
Corner.
Okay, corner. Okay.
So 2 comma 1, and that's P, and 8 comma 1. Now I definitely think it's not worth taking the time to put a proper grid on this. You'll notice I just approximate my positions. So we've got some choices. We could have a rectangle like this, or we could have a rectangle like this.
Mm-hmm.
And I think that's it. So let's see. Could 2 comma 8, which would be, we could say that would be 2 comma 8. Can that be another vertice?
Mm-hmm.
Okay, how about 8 comma 2?
No. Well, it could if it's... No.
Yeah. Yeah, it could. In other words, the rectangle could be like that.
Mm-hmm.
It could be this rectangle here.
Mm-hmm.
Okay, so 2 comma minus 8.
That's the same as 2 comma 8, so you can do that.
Okay, how about minus 2 comma 8?
No.
All right. And I don't know of a better way of doing that other than just going through each answer and see if it's until you come across the one that doesn't fit.
Mm-hmm.
Okay. A circle whose center is at 6 comma 8 passes through the origin. Well, it seems like we just did this. Only the last one was 3 comma 3. This one is 6 comma 8. Which of the following points is not on the circle?
Well, you would have to go through them again.
You can do this by eye, in other words, by plotting each point and trying to figure out whether it makes sense, whether it's on the edge of that circle or not. But there actually is a better way to do it. You can do it algebraically if you know the equation of a circle. Do you know the equation of a circle?
Equation of a circle? I'm not sure what you mean.
Well, if a circle is at the origin, this is its equation. But this circle has its center not at the origin, so its equation is x minus h squared plus y minus k squared equals r squared, or r is the root.
What was the other one you said? That if it was x squared plus y squared?
That's a circle whose center is at the origin. In other words, if I had a circle that was just centered right at the origin, then this equation would be simpler. It would just be x squared plus y squared equals r squared.
But then it would be 0 because the center is 0.0.
Right. However, this problem we have, it's not at the center. So the equation of this circle is going to be x minus 6 squared plus y minus 8 squared equals, well, that distance there is the hypotenuse of a 6, 8, 10 triangle.
That's 10.
So it's 10 squared. So there's the equation. And if we wanted to see whether a point is on the equation, we just plug it in. In other words, just plug in 12 for x and y for 0, and does this work? And yes, it does. We plug in 12, we get 36 plus 64 does equal 100. And we would just plug in each point until it does not agree with that equation. And that would be the pure mathematical way to do it.
Mm-hmm.
It may be simpler to take a look at these points. I don't know. It's hard. If I plot 12 comma 0, do I know that that's necessarily 12 comma 0? In other words, when they say on the circle, they mean on the circumference, not
Mm-hmm.
in the circle. It can't just be inside the circle.
No, yeah, I know.
Okay.
Well,
So,
then, okay, so 6 minus 6 is 0, and 0 squared is 0. Plus minus 2 minus 8, that's minus 10
okay.
squared
Okay.
is
So
100.
so both of these are on.
Mm-hmm.
How about this
Well,
one?
16 minus 6 is 10 squared is 100 plus 0, so that's also 1 there.
Okay.
Minus 2 minus 6 is minus 8, so that's 64 plus 12 minus 8 is 4, squared is 16, so that doesn't work.
Does or doesn't?
It doesn't.
Okay, good.
This
Because we
is
were
what
running
makes
out
it
of one. I had already looked at this one, and this one looks like it works also.
yeah.
So D is the only one. And this really is the only one, the only way I really know how to do it.
Okay.
I guess you could, there is another way. If you take each of these points and find out its distance from 6 comma 8, has to always be 10. So that you could get away with not knowing any of this. If you don't know the equation of a circle, but you know the distance between 2 points, then you could figure this out, because the distance of all of these radiuses have to be 10, no matter what point it's going to. Okay.
Mm-hmm.
Let's see, minus 5 comma 2 minus 2 comma 6 5 comma 6 and 2 comma 2. Looks like a parallelogram. That is certainly parallel to that. I don't know if that slope is the same as that slope. It says it's a parallelogram, so we need the area of this parallelogram. What's the formula? What's the formula for the area of a parallelogram?
Is it base 1 plus base 2 times height?
That's the trapezoid.
Oh.
And in a parallelogram, these bases are the same because it's a parallelogram. It's base times height. The only thing is it's vertical height. So we need
this. You have to draw that little stipply. Yeah,
right. Okay. But that's pretty easy to calculate in this instance. What's the base?
Oh, that was the distance part, right? The slope?
Well, you don't really need the distance formula if it's a horizontal or a vertical line. Just take the differences, the distance between the two x values. What's the
7.
distance? Yeah. So that's the base. What's the height?
Um, 4?
Uh-huh.
28.
Yep. Now, if we were to answer 8, what's the perimeter of that? Then we would have to use, we know this is 7, we know that's 7.
14.
We would need to figure out what this distance is here.
But then you would just use the distance formula.
Or we could see that it is a 3, 4, 5 triangle.
Oh, yeah, okay.
So the perimeter is 14 and 10, 24.
Well, why? Oh, because you know that
I know this is minus 2 right here. And I know the height is 4 because 6 minus 2 is 4.
Okay, and so you just said, well, from minus 5 to minus 2, that's 3.
Uh-huh. Okay. But always, they stick so many 3, 4, 5 triangles into these problems that you should almost come to expect it. In other words, rather than thinking, okay, I've got to figure out the distance formula between this point and this point, it's worth saying, is this maybe a 3, 4, 5 triangle, and then I won't have to figure it. I'll be able to do it instantly. Okay, we need 9. Should we go to the tests?
Yeah.
All right. Let's see. We got through the horse question, 29, about 30. Let me move it over out of the way a little bit. Don't need to blow this up as much because it's clearer, easier to read. That's the first thing we should do here.
You should put the numbers into order.
All we know is x is somewhere in between there. We don't know what it should be, but we know the median is 11.
So that's like the median number.
The middle, right.
Mm-hmm. So like if x was...
Without the x, what would the median be here?
10.
Okay, so does x have to be bigger than 11 or smaller than 11?
I would say bigger than 11.
Right, because if x was 5, then the median would be 10.
Mm-hmm.
So if x was 11, the median would be 10 and a half.
Mm-hmm.
So x has to be at least 12.
Mm-hmm.
And if I make x 12 or higher, then the median is going to be halfway between those two, which is 11. So what's our answer?
E.
Okay. Now this problem looks, when I first looked at this problem, I thought it was a complicated work problem because it involves rate of production and all of that. But it turns out that it's not. It's actually pretty easy.
Okay, you have machine X, and machine Y, and machine C. And machine Y is equal to...
Machine Y will do 35 widgets per day.
Yeah, but it works 1/3. It works 1/3 of what X and C can do.
So what is X going to do?
It's 1/3 plus 35.
If 35 is 1/3 of what x can do, and notice the comma after x,
So 2/3.
so it's not 1/3 of what x and z, it's 1/3 of what x.
Okay,
So
so x is 2/3. 2/3.
what number would x have to be so that y would be 1/3 of it? We know that 1/3 x equals y. So what is x? If we solve this equation for x, we get 105. So x can do 105 widgets per day.
Oh, because you just drag it over and say, you just
Right.
multiply
Multiply
by
both
the
sides by
numbers.
3. Right. Okay, so now what can z do? If z is twice y, hi, hi.
70.
Okay, now total them all up.
$210.
See, it really wasn't a work problem at all. It did not involve this equation.
Mm-mm.
And one could have maybe spent time trying to apply that equation and wasting a lot of time. I don't know. Interesting how when we jump back and forth between these things, we keep encountering the same. Here's a coordinate plane question.
Mm-hmm.
Okay.
On the XY plane, what is the unit area of the quadrilateral?
Quadrilateral. Mm-hmm.
Quadrilateral defined by the XY coordinate pairs.
Well, at least they gave us a couple of parallel lines. They're not going to make it terribly difficult. And 2, 3. So what do we have here? What figure are we looking at? What shape?
It's a the one I can't explain. It has
Trapezoid. That's the one that you gave me the area of before, which is base 1 plus base 2.
Like,
Okay. So that's what they're asking for. So what is base 1? If I call this base 1.
base 1 is 5 plus 2, 7.
And base 2.
Minus 1 and 3.
Okay, and the height.
4.
Okay, it's good. It's a good ability to be able to tell the distance between a positive number and a negative number quickly without...
I always say it's going to be positive anyway.
Right, it's always going to be positive, so it's all we need to figure out is how far is it from here to the x-axis, and then from the x-axis to there, add those two numbers, you got your answer. So the area is...
Well, that's 11. No, okay, never mind. That's 10, that's 5, that's 20.
Okay. D, yeah. Okay, a bag contains 185 cards.
160 try again cards and 25 winner cards.
This is a counting and probability problem, which is one of our sections we're going to cover next. right after coordinate geometry covers counting and probability. So we're getting to it quicker.
Okay. How many try again cards must be removed from the probability of selecting a winner card among 25 such cards to be 1/6?
So what's the
Okay.
probability right now of getting a winner?
I'm not really good with these problems.
Okay, it's the number of winners is 25
5 out of
divided by the
185.
total possible events.
So 185.
Okay. And what we need to do, how many try again cards must be removed? So we're going to remove some from the try again cards, some amount, we'll call X, such that this whole thing is equal to 1/6. Because right now, 25 divided by 185 is not 1/6. So we need to solve this or back solve it. Depends on whether you'd rather do the algebra.
Because you end up doing like, if it was like 5 over 185, you would end up with 5 over 37, which is kind of like a weird.
Okay. So what do we need the denominator to be for 25 over the denominator to be equal to 1/6? Think of quarters in your pocket. Well, no, that doesn't work for somebody from Denmark. Excuse me.
I mean, I'm just thinking, for example, if it had been 175.
150.
Yeah, I know, but
If you had six quarters, you'd have $1.50. So 1/4 must be 1/6 of 150.
yeah,
So to make this equal 150, X has to be what?
35.
Right. Okay, now that was kind of the strange way to solve it. Let's solve it properly, mathematically.
Yeah, what I did was I went down to like numbers I knew, like, just when I said like 100, well, if it was 175, it would be 1/7.
Okay.
So therefore, that's how where I was going. So like it needed
Right.
to go like, further down.
Look at how direct it will solve if we do the simple step of cross multiplying. I
Okay.
cross multiply, I get 150 equals 185 minus X. Bring the X over there, bring the 150 over there, X equals 35.
Yeah. That was really easy.
Okay. I gotta go to another page here. Maybe we'll get some. No, I'm not sure what page I was on here. What was that part? Was that 33? I think it was. Yeah. Okay. Good. Finally a data sufficiency. I say that only half serious.
Yeah. What is the fifth number in a particular series of numbers? If the 10th number in the series is 450.
How much do you know about series?
Not a lot.
Okay, there's all kinds of different series, and they're not telling us what kind it is. But if we look at statements 1 and 2, it starts giving us more of a clue as to what kind of series they're talking about. We don't know what kind it is. What kind of series is number 2? The two kind of series that you're probably familiar with are arithmetic and geometric.
Mm-hmm. Well, then that would be the first one you said.
Which one are we looking at, number 1 or 2?
2.
Okay, so does 2 work? 2 says each number in the series is 3 times the previous number.
Mm-hmm. You would be able to figure it out.
Can we work backwards and figure out what the first number is if we know the 10th number is 450?
Mm-hmm.
Okay. So if we know the first number, we'll be able to figure out the 5th number. So 2 is a yes.
But wouldn't we just be able to figure out the 5th number without figuring out the 1?
Yes. Yes, absolutely. But the essence is we're not going to do it anyway. One of the key things of data sufficiencies is not solving, but figuring out whether you can solve. You don't want to waste the time to actually do this, as long as you understand that you could do it.
Mm-hmm.
Okay. How about number 1? The 9th number in the series is 150.
I would say no, just because you don't know.
You don't know what kind of series it is. You don't know what kind of series it is. For number 2, this tells you it's a geometric series.
Mm-hmm.
So you know exactly how every number in the series relates to every other number. But it might be an arithmetic series where you just add a given number each time. In other words, if I add 3, that's a series. So that's called an arithmetic series. Well, number 1 doesn't tell us what kind it is, so knowing the 9th number is 150 doesn't really help.
Mm-hmm.
So we want to solve for x in terms of y.
Yeah, and y is not equal to 0.
Okay.
And x is not equal to y.
Okay. What can we say to simplify this? Rather than cross-multiplying, do we need to cross-multiply? Notice that if we cross-multiply, we're going to bring in x squareds and y squareds. Do we need those?
Mm-mm.
Numerators are the same, so the denominators are what? If I have two numerators that are equal and the fraction is equal, then the denominators have to be equal.
Okay.
So now how do we solve for, we want x in terms of y.
So y would be equal to x plus x. Oh, you want the other way around.
No, I'm confused because I get y equals 0 now. Minus y equals 0. If I subtract x from both sides here, I get minus y equals 0.
Yeah.
This doesn't help.
No, also because there's no x's in the answer keys.
Well, there shouldn't be any x's, but there should. Oh, right, because we're trying to come up with an x equal to a function of y.
Mm-hmm. If you put 0 into y, you'll end up with x. Right?
Yeah. let's just take one more step here and do cross multiply them just to see whether it produces anything interesting. X squared plus xy, this is the difference of squares, x squared minus y squared. So that does kind of help. I think that takes out that. Now I have xy equals minus y squared, and if I divide both sides by y, I will get x equals minus y. Wow.
Oh, so A is the answer.
Yeah. But I'm shocked. I'm shocked that it made a difference because interesting. Okay. Problem 36 is probably one of the more complex type solid geometry problems. It's just we might not have time to do the whole thing, but let's just look at it briefly and figure out how we're going to do it. We've got a cube with a hole drilled out. How many square inches is the total surface area? In other words, if we wanted to paint the outside of that and the inside of the hole, what would the total surface area be?
You would have to find the surface area of both.
Yeah, we would have to find the surface area of the cube, and there's two sides that have a missing part. In other words, this side here, you're going to have to subtract out 1 square inch from that one and this one. So you add all of those 6, and then you add the 4 inside surface areas of this rectangular block, not counting the ends. So this one isn't really a hard problem, it's just long. This is going to take probably a couple of minutes to do, but quite doable. We'll start with that one next time. Well, we won't start with it. When we do the test, we'll do that one. When are you taking your test? Do you have it set?
Yeah, it's in September 26th.
Okay, that's a couple of weeks. All right.
Yep.
Sounds good. And we are square as of right now, I believe. That's my bookkeeping says that.
Yeah, I owe you for today, right?
No?
Oh.
No, according to my books, you paid for today.
That's good, because I was in doubt, so I was like, I couldn't remember if I'd paid you for last Monday, so I just paid, and then I was like, oh.
No, I keep pretty good accounting because of this scheduler I have. It's always easy for me to go back and see, and then PayPal, of course. So
yeah,
pretty easy to reconcile on my end.
Well, I did for like the first, and then I forgot to put a cross. I have a little thing too that I just cross out, and I guess I forgot.
Well, one thing you might have gotten confused at was our first session only lasted about 3 minutes because my computer crashed. So that didn't count as your first free session. And then the next session we had was a free session.
Oh, okay.
You might have gotten off with that.
I got lost, yeah.
Yeah. But we're square as of right now.
That's good. Okay.
Okay, Cecily.
Have a good Friday.
You too.
That's okay.
And I will talk to you next time.
Talk to you next time.
Okay, bye-bye.